Well, I'm excited to have Dr. Sarah Broccard with us today. She received her PhD in evolution and behavior through the Department of Neuroscience at the University of Lethbridge in Alberta, Canada. She moved to San Diego in 2014 to study honeybees at UCSD and to hang out with her husband, a collaborator and computational neuroscience also at UCSD. Dr. Broccard-Bell's work, drawing on ideas from biology, neuroscience, and computer science, focused on understanding how the organization of honeybee colonies allows them to make decisions in changing environments. Last March, she and her husband returned to Canada, where Dr. Broccard-Bell has begun a new job working for a Canadian company to develop environmentally responsible honeybee health products. It's our great pleasure to welcome Dr. Heather Broccard-Bell.
Thank you, everybody. Thank you so much for inviting me. And thank you, Sarah, for those beautiful readings. It's hard for me to follow that. And I'm glad that I had a little bit of a reprieve there while Alexis introduced me, because I don't think I would have been able to start like right away. So I'm going to share my screen here and I will start my presentation. All right, so the premise of my talk is to ask you guys a question, whether you think that honeybee colonies can be intelligent. And a lot of my research, as Alexis mentioned, focused on sort of drawing parallels between neuroscience and honeybees. And so I'm going to tell you a little bit about that and why I think, or I'm going to try to convince you, that honeybee colonies can in fact be intelligent. So before we can ask that question, of course, we have to define what we mean by intelligence. And you can ask, 8 different people what they think intelligence means, and you'll get 8 different answers. You can ask 8 different scientists, they'll give you 8 different answers. Here's a definition that I'm going to give you. It's not the only one out there. So what is intelligence? Intelligence means making appropriate decisions given the information at hand. And that's actually a really important part. Because a lot of times, people and other kinds of animals are making decisions, and we see these decisions from a different perspective, and we say, well, why did they do that in that particular instance? And it may not be that they're not intelligent. It may be that they weren't able to see all of the information that we are able to see. So given the information at hand, what was the appropriate decision to be made in that circumstance? Number 2 is changing your behavior, changing your mind when the circumstances change. So you can make an initially intelligent decision, but if the circumstance changes, you have to sort of be willing to change your mind. That's what being truly intelligent is. So making appropriate decisions and then recognizing when those choices aren't working anymore and changing it. Okay, so here I've told you what intelligence is. And again, my goal for this talk was to try to compare the behavior of honeybee colonies with how a brain works. And instead, though, of telling you how a brain works, which would put you guys all to sleep in the next 15 seconds, I am going to hopefully give you an analogy that will both be more familiar and easier to understand, and also make the parallel with honeybee colonies hopefully more clear. So, and it's also a circumstance that you might not think of as being intelligent. It's something that you're probably all familiar with, but maybe you don't think of this as being an intelligent behavior. So let's imagine that in San Diego, 2 new restaurants open up. So we've got restaurant A and restaurant B. Initially, nobody knows anything about either one of these restaurants. Let's ignore the fact that there could have been marketing or whatever else. Let's just pretend that nobody knows anything about them to begin with. But restaurant A serves objectively good food. Restaurant B serves not so good food, right? So at the beginning, when these 2 establishments open, people kind of visit them about equally. But as time goes on, people start to talk to one another. They tell each other about their experiences. Restaurant A was really good. I really enjoyed it. You should go check it out. And then more people start going to restaurant A. On the other hand, people going to restaurant B have a negative experience. They tell their friends, and then people start avoiding restaurant B. Over some periods of weeks, you see that people in San Diego start to prefer to go to restaurant A. More people are visiting restaurant A. Of course, there's always new people that don't know anything about either restaurant that, you know, might happen to end up at restaurant B. But given enough time, the group, which is just the population of San Diego, makes a decision to visit restaurant A because restaurant A has objectively better food. So I would argue that in that case, the group, the population of San Diego, actually made an intelligent decision because they chose the restaurant that was objectively better. Now, of course, as I mentioned before, there's all these other complications when we're talking about human behavior. You know, sometimes people lie about stuff. There could be unethical marketing and all these other sorts of things happening. But if that isn't happening, and even if it is, we can argue that, you know, that's still intelligent decision making. It's just that the information that people had access to wasn't correct, right? Over enough time, again, the group, the population of San Diego picks restaurant A over restaurant B. And this was in the absence of anyone, there's sort of like not one person telling them that they have to go to restaurant A. So the group made an intelligent decision without any help from the outside. So what happens if something changes? What happens if, say, the chef at restaurant A goes on sabbatical and they bring in someone else who isn't as experienced? And now all of a sudden you've got what was formerly a good restaurant serving bad food or worse food. And restaurant B realizes that people are being driven away by the quality of their food. And so they hire a new chef. So now you've got restaurant B that was formerly bad, serving good food. Now, if these changes happen at about the same time, you see what you had seen in the recent past, which is most people are going to visit restaurant A because that's the information that they have. The most current information that they have is that restaurant A is still good. But once again, as time goes on, people start actually going there and having a good or a bad experience, and they start telling other people, you know, they can have conversations or they can write Yelp reviews or whatever else, but they're sharing information. And eventually, the group that had formerly chosen, quote unquote, restaurant A, now will shift to restaurant B. So we've got group behavior that meets at least my definition of what is intelligent. So you've made the appropriate decision, given the information at hand, and you've changed your mind when something changes. And once again, and it's important for my point here, no one told anyone to switch. No one told anyone which place to go. Now, by no one, I mean no one, there was no law that was enacted. There was no government organization telling them that they needed to go there. Of course, people are telling each other their experiences, right? And there, of course, are people who are more or less influential, but there's no single person that's directing the behavior of this group because it's really a loosely connected group. You know, they're all people that live in San Diego or at least visiting San Diego. So that's how groups of humans can make decisions. How is that related to brains? Why did I tell you that story? Well, like I said before at the beginning, I didn't want to explain to you how a brain worked in detail because that's complicated. But how a brain works is actually very similar to how those humans made decisions. So both human groups and brains are made up of many individuals. A lot of times we don't really think of brains as being made up of individuals, but they are. The functional unit in a brain is a brain cell or a neuron. In a group of people, of course, the functional unit is a human, right? So in both brains and groups of people, we have individuals. The individuals in both of those systems gather information and share it with each other. In the human group, they gather information by having experiences at the restaurant, but also by talking to each other. So the information that someone gets before they go to a restaurant at all is usually going to be other people telling them what their experiences were like. But once they go there, then they have their own experience to share as well. So they have their own experience on top of whatever they were told, and then they can share that with other people. Brain cells actually work very similarly. So brain cells communicate with their neighbors. So they get information from the surrounding brain cells. They also get information from the outside, from the sensory organs that collect. So when you taste something, when you hear something, when you see something, all that information is getting sent to your brain cells, right? So they're having direct experiences like going to a restaurant, and they're getting information from their neighbors. So from the other individuals in that group. which is other brain cells. All of the individuals, be it brain cells or humans, have their own individual behavior. That's because both humans and brain cells, surprisingly enough, have their own unique set of characteristics. So just like every one of us is kind of like our own special snowflake, so are brain cells. Brain cells have each and every single brain cell has a slightly different set of properties than its neighbor. So they're not all identical clones. They can be different. So they can react slightly differently to the information that they get, just like people do. And this might come as a surprise. In the groups of people, nobody's telling them what to do. In brains, there's no director brain cell that directs the brain in carrying it out its activities. Now, if you're an individual that has a brain, your brain is doing all this stuff. The individual's brain cells in your brain are working together, sort of not in an intentional sort of way, but that's what happens. And whether or not you do something, so the decision that you make as an individual is based on the overall, what's happening over all of those brain cells together. Just like if we look at the groups of people visiting restaurants in San Diego, what's happening isn't a function of a single person, right? Because people can be accidentally going to the bad restaurant, or maybe they prefer to eat bad food, but the group as a whole is largely visiting the good restaurant, right? And similar to brain activity, where you're going to make a decision, that decision is going to be based on the collective activity of all the brain cells in your brain, but not every single one of them is going to be sort of endorsing the same decision. There might be one or two that are saying no. So it doesn't really matter from that perspective what an individual is doing, but collectively they're making a decision. Okay, so we've got humans choosing restaurants, we've got brains and brain cells acting together. How does this relate to bees? But before we get there, so we've got this intelligent behavior, right? So we've got human groups that are intelligent. We've got individual humans. Most people would agree that individual humans can be intelligent. Some evidence to the contrary. And the question is, maybe humans can be intelligent as individuals or in groups just because we have really complicated brains and we have really complicated ways of communicating with one another. So maybe that's what it comes down to. Like we've got this intelligence emerging from those, the way that we're put together, again, because our brains are complicated and we have complicated ways of talking to each other, language and writing and the computer and everything else. So maybe that's just it. Well, let's consider the honeybee. So honeybees have 90,000 times fewer brain cells in their brains than humans. Humans have about 86 billion brain cells. Honeybees have slightly less than 1 million. So 90,000 times fewer. Modern neuroscience, by and large, says that the more brain cells you have, the more intelligent you can be. So if that's the case, then honeybees should be less intelligent. However, just like us, honeybees also need to solve problems. So they need to make good decisions, and they need to do it in a world that changes all the time. So honeybees, the ones that we're used to, these ladies here, have been introduced. They're originally from sort of Europe and Asia, and they've been introduced to every continent now except for Antarctica. So they're everywhere. Well outside of their native range to which they're adapted. So they live in this world that isn't constant, and not only that, it's a world that many of them are actually not even evolved to live in. So they need to solve problems in a world that changes all the time. What kind of problems do they need to solve? Well, lots of them, but I'm going to talk about one in particular because it's more related to the restaurant analogy that I gave you, and also it happens to be the subject of what I studied for the last 7 years in San Diego. And this is the problem of gathering food. So honeybees live in these colonies. I'm sure you're all aware that they live in colonies. What's a honeybee colony though? Well, a honeybee colony can be anywhere from about 100 individuals to 100,000 individuals. So they can range in size from really small to really large. I think probably most of you are aware that the honeybee colony has a queen, and then there's a bunch of other bees in there, right? All the ones in the picture here are workers. Workers are actually all female, and they're all sisters. So a honeybee colony is actually a big family. The males look a little bit different. Their eyes are bigger and their bodies are actually a little bit larger. Those are called drones. There are usually not as many of them, actually always not as many of them in the colony as workers. And that's because their only job in life is literally to mate with a queen. That's all they do. The workers, again, all the females in the colony, they do everything else. And honeybee life is complicated. So they raise babies, they feed their babies, they do housekeeping, they do undertakings, so removing dead bees from the colony, they do guarding, so some of the bees are guarding the entrance of the colony, and some bees go out and forage for food. Honeybees eat nectar and pollen, so they have to go find good flowers that have nectar and pollen and bring them back to the colony. Honey is made out of nectar from flowers. Just to get back to the colony organization for 1 second further here, the queen doesn't actually tell them what to do. So a lot of people are under this misconception that the queen is directing the behavior of the colony. At sometimes that is kind of true. So if they're moving to a new location, everybody in the colony kind of follows the smell of the queen. So in that instance, she kind of is telling them what to do, but she doesn't tell them what to do in their day-to-day lives. So she doesn't tell them, for instance, how to gather food or where to gather food. She has nothing to do with that. Her job is to lay eggs. The queen is everyone's mother. Nobody else in the colony lays eggs under normal circumstances. Okay, so we've got this honeybee colony. Individually, honeybees have much smaller brains than humans, but they need to solve problems in worlds that are changing all the time. And one of the problems is gathering food. How do they do that? Well, it turns out that honeybees have their own version of restaurant reviews. So just like you can write a Yelp review and read someone else's Yelp review, honeybees can do the same thing for patches of flowers that they visit. And as a consequence of this, they're able to really optimize how they gather food, which means that they're able to take advantage of the environment in a much more efficient way than other groups of animals are. So the way that they do this is they basically have two different sets of signals. So two different ways of communicating with each other. We've got the waggle dance, which is kind of like their version of a positive review of a restaurant, and a stop signal, which is kind of like their version of a negative review. And I'm going to show you what they look like. Probably most of you have heard of a waggle dance or heard that bees communicate using dances before. Maybe you haven't seen it though. Oh, what happened there? Okay, so here we go. So this on the left-hand side here, you can see this bee has come back from a flower. She's got pollen stuck to her legs and she's making this weird motion. She's wiggling her butt. She's stopping, turning. So wiggles her butt, walking in a straight line, turns around. And you can see these other bees in the colony are actually watching her, right? You can see they're touching her with their antennae. So she's actually communicating. I'm not going to go into a lot of detail here, but you can ask me later on to explain exactly how this works. But basically this movement tells the other bees in the colony how to find the good patch of flowers that she's been to. So bees will only do this if they think that the quality of the flowers that they're visiting is high. So they'll come back to the colony and they'll basically tell other bees how to find it, right? And other bees that are watching this waggle dance now get the directions, the distance and the direction from the colony, how to get to that good patch of flowers. And this is all with a brain that has less than 1 million neurons. Amazing. And this is on the individual level. So the longer she does that dance for, the more bees that can watch her and the more bees that can find that same location. So basically, the longer she does the dance, the better she thinks that resource is. And the more she thinks that the colony should sort of redirect more foragers to go to that location. And that way, honeybees are able to take advantage of the very best flowers, much more so. There are closely related species of bees like bumblebees that don't do this sort of thing. In a bumblebee colony, bumblebees also live in colonies, they don't talk to each other. So basically everyone that goes out to collect food and they eat the same kind of food has to start afresh every day. So the best they can do is remember where a good patch was the day before, but they don't talk to each other. In the honeybee colony, the word can spread basically. So that's a positive restaurant review in a honeybee colony. Negative review in a honeybee colony is this thing called a stop signal. So we've got a waggle dancer, once again, I'm going to play this clip a few times because it's a little bit hard to see. We've got a waggle dancer. And then you see another bee will come in, this bee here, and butt her head against the side of that waggle dancer. And if you watch closely, that waggle dancer then pauses, right? So she stops for a second. That's actually why the signal is called the stop signal. At the same time as this head butter bee hits this waggle dancer, she actually makes a sound. And I'll play the little sound for you here. It's like a little beep sound, right? And it's actually the beep that makes that waggle dancer pause for a second. Bees are really sensitive to vibrations. In fact, a lot of their communication, both in the waggle dance and in the stop signal, is about vibration more than anything else. So that little vibration makes the waggle dancer stop for a second. And although it doesn't always stop her from continuing waggle dancing, sometimes it does. So we call this an inhibitory signal. It just sort of dampens down the propensity to spread that message. So, and ultimately what the effect of that is that fewer bees will go to that flower. Now, why would they do that? Why would they give a flower a negative review, especially a flower that was good enough to perform a waggle dance for? Well, as the day goes on, predators change location. So a spider might all of a sudden be on that flower. And if a bee goes there and she has a close encounter with a spider, she's going to come back and find other bees that are doing that waggle dance and say, stop, like, don't tell anyone to go there anymore, right? It's bad now. Another time that she would do it is if that flower is crowded. So if there are too many other bees hovering around that flower, then that's like not a really great place to eat anymore, right? So she comes back and she says, stop, right? So it's not exactly the same as the restaurant reviews and telling each other what's a good and bad restaurant in San Diego, but it's very, very similar. So over time, bees are able to forage the most at the best flowers. And if those flowers start to become bad, they can shift to better ones so they can make good decisions. And they make good decisions in ways that are very similar to how brains work and very similar to how groups of people work. So I ask you, given the evidence that I have just presented to you, what do you think? Do you think honeybee colonies are smart?